Okay, so okay, so let me open this up. Okay, so this is start of assignment 2, and there are a couple of topics that were covered in assignment 2. And what this question is dealing with is basically how to convert numbers expressed in the standard notation into what we call the scientific notation. And if you watch the videos, you'll see that basically in order to get from the standard notation to scientific notation, you have to move the decimal point to the immediate right of the first non-zero digit. Now, in some cases, that means you have to move it a number of places to the right. In other cases, you have to move the decimal point several places to the left. All right. So let me also say that when it comes to a number expressed in scientific notation, there are two parts. You have what is called the coefficient, and then you have the other part which is called the exponent, right? And the exponent is normally placed in a position where 10 is written down and then it's raised to that exponent. So let me do the first couple of examples so that you understand how to do these conversions. So the first one is 34,000. So basically, oh, by the way, hold on, check something here. Not sure if I published it for the oh, okay. So for those of you out there in Zoom, you should be able to download it. All right. So it's available for you to follow along. All right. So as I was saying, so you're given 3,400 and you're asked to calculate, or I should say convert it to scientific notation. So basically, in the case of 3,400, we all understand, even though it's not shown here, that there's a decimal point that would normally be here, right? And as I said before, we need to move that decimal point until it's arriving at the immediate right of the first non-zero digit, which would be the 3, right? So that means that in this case, you have to move the decimal point 1, 2, 3 places to get it right here. So the result of that is that you're going to end up with 3.4, and then you have to multiply by 10 raised to a certain number, which represents the number of decimal places that you moved it to the left. So since we moved the decimal point 3 places to the left, that will be 3.4 times 10 to the 3. All right. So this part here, as I was saying earlier, that's called the coefficient. All right. And the 3 here, in this particular case, will be the exponent. So those are the two parts that we would normally identify when a number is expressed in scientific notation. All right. Okay. Any questions about what I just did, the first part? Any questions? Any questions? Now for the second part, things are a bit different because in this case, the decimal point is here. And in this case, that means you have to move it several places to the right until you get it to the immediate right of the first non-zero digit, which would be the 2. So in this case, you move the decimal point 1, 2, 3, 4, 5. So the coefficient in this case would be 2.3 multiplied by 10, and this is where the things are a bit different. This will be 10 to the minus 5, right? Because in this case, you're moving the decimal point to the right, right? If you move the decimal point to the left, then the exponent is positive, but if you move it to the right, then the exponent is negative, all right? So that's basically how that is done. All right, so if you understood what we did in A and B, how would you do C? In C, you're given 101,000, right? So again, the decimal point is understood to be here, right? So where do you want to move it to? You want to move it to the left, right? How many places? 1, 2, 3, 4, 5, right? So the coefficient is going to be 1.01 and you multiply by 10 to the what? You sure? How many places did we move this decimal point? 5. Exactly, so 1.01 times 10 to the 5. All right, any questions? Any questions? Okay, what about D? All right, so you're gonna move it 1, 2 places, and the answer here is gonna be 1.0 times 10 to the what? Minus 2. All right. Okay, what about E?
12.501
4.501
times 10 to the 1 power.
10 to the 1, exactly. What about F?
1.0 times 10 to the 6 power.
Well, actually, it's going to be 1 times 10 to the 6. I'm going to explain why later on, maybe not in, well, maybe later on in this assignment, all right? But the answer is just going to be 1 times 10 to the 6. All right? What about G? I just noticed there are 2 G's. This should be an H. Okay, so what happens in the case of G?
0.71
6.71
to the times 10 to the third power.
10 to what?
Third power.
I'll take it to third.
Negative 3, exactly. Okay, and then finally in H,
Be 4.5 times 10 to the 0 out.
times 10 to the 0, exactly. Anything raised to the 0 is 1, so 10 to the 0 is 1, so that's what that's done, all right? Okay, any questions about any, yes, sir?
So for the last one, if I put 4.5 times 10 to the 0 power, it's the same, right, 4.50, right?
Yeah,
Okay.
it's just that you write it this way if you're asked to do it in scientific notation,
Oh,
all right?
Wait, is that 0?
Yeah, 10 to the 0, yeah. Mhm. Yep. Okay, so if you understood what we just did in this part, it's okay for me to clear this, right? Can I clear? Okay, so if you understood what we did here, then you should be able to do this, which is the reverse. Right? They gave you the numbers in scientific notation, and they're asking for the equivalent value in standard notation. So what do you think the answer for I is? Oh, let me turn on my pen here. Okay, what's the answer for I? 2, 3, 0, 0. 1, 2, 3. We need one more. All right, so that would be the answer. 23,000. Yeah, you're right. Okay, what about J?
0.00176.
0.00176. What about K? 1.901 times 10 to the minus 7.
0.0000001.01.
6 zeros. Whoops. So, and then 1901. All right, everybody see that? Okay, what about L? 8.65 times 10 to the minus 1.
0.865.
0.865 is correct. Okay, what about M? 9.11 times 10 to the 3.
5,100.
9,110,
10.
exactly. What about N? 5.0 times 10 to the 1.
54.
Actually, it's 54.0. Again, I'm going to explain why shortly. And then we get to O, 1.76 times 10 to the 0. That's easy. It's 1.76. That. And then what about P, 7.4 times 10 to the minus 5.
0.00074.
0.00074. Okay, very good. That's how that is done. All right. Let me clear this. Let's go down. Okay, so in this case, this question is asking for you to determine the number of sig figs in each of the following measured quantities. So just to briefly recap what was covered in the videos, basically to get the number of sig figs, there are certain rules that you have to adhere to. If you're given a question and you're given a measurement, then you know that there's a certain number of sig figs associated with it. And just to briefly recap the rules, the first rule, which is the easiest, is that all non-zero digits are significant. So basically all digits from 1 through 9 are significant. And then all the other rules have to deal with zeros in particular situation. So for example, if you have zeros before the first non-zero digit, then that zero would not be significant. If you have zeros sandwiched between two non-zero digits, then those zeros are significant. If you have zeros at the end of a number and there is no decimal point, then those zeros are not significant. If you have zeros at the end of a number and there is a decimal point, those zeros are significant. And I think that's it. I don't think there's any other rules I need to get into. So with that said, let's look at number 2. And in the A part, they gave you this number right here, 0.000289, right? So the question is, what's the number of sig figs, right? And the answer is that, well, these digits are significant because they are non-zero digits, right? But these are preceding zeros, zeros that comes before the first non-zero digits. Those zeros are not significant, right? So therefore, the number of sig figs here is 3 significant figures in that case, right? Okay, any questions about it? Any zeros that comes before the first non-zero digit will not be significant, all right? Now, in the case of B, they gave you a number expressed in scientific notation, right? 3.50 times 10 to the 8. Whenever you're given any number expressed in scientific notation and you're asked to determine the number of sig figs, you pay attention only to the coefficient. You do not look at the exponent, right? To determine the number of sig figs, right? So in this case here, we have 3.50. We don't pay attention to this, right? And you notice that a 0 is at the end here. And if you remember what I just said, if the 0 is at the end of a number and if there's a decimal point, then that 0 is significant, right? If there's a 0 at the end of a number and there's a decimal point anywhere in that number, then that 0 is significant. So therefore, that means that in addition to the 3 and 5 being significant, this 0 will be significant. So therefore, again, the answer would be 3 significant digits or figures. All right? Okay. So based on what we have covered so far, can you tell me what the answer for C is? How many significant digits are represented in the case of C? 6. Right, that's correct. Because we have a 0 at the end of a number here, right? And there's a decimal point, so that 0 is significant. And we also have zeros that are sandwiched between non-zero digits. We have this 0 here and this 0 here. So those zeros are significant. So now we have 6 significant digits or significant figures represented. Okay, and then what about D? 4 significant figures, correct? Because again, you have a 0 that is sandwiched between non-zero digits. All right, very good. So let's clear this and move on to number 3. Oops. Hold on. Okay, so in the case of number 3, we're dealing with mathematical operations, right? This is going to be very important, not only for this, but also for, future situations where you're given problems and you have to carry out calculations and so on. And the reason why it's important is because you have to round off your answer appropriately after doing your calculations. And again, there are some rules concerning how do we round off, your answers. The rules have to deal with addition and subtraction as one category and multiplication and division as a separate category. So I'm going to deal with multiplication and division first. So if you are multiplying and or dividing numbers, then your final answer must be rounded off to the lowest number of significant figures of the numbers involved in the operation, right? So if you're multiplying and or dividing numbers, right, you need to round off your answer to the lowest number of significant figures of the numbers involved in your mathematical operation, all right? So that's the rule for multiplication and division. Now for addition and subtraction, if you are adding and or subtracting numbers, if you are adding and or subtracting numbers, you round off your answer to the lowest number of decimal places. All right? If you're adding and or subtracting numbers, you round off your answer to the lowest number of decimal places. Let me give a quick example. So let's say you're given, I'm just going to make up something here. Let's say you're given 2.75 and you're adding to that 550.7. All right. So take your calculator and you add 2.75 plus 50.2. And I got 52.95. Right? Now in this case here, you have one decimal place here, and you have two decimal places here. So that means you have to round off this here to one decimal place, which means that in this case, the answer will be 53.0. See that? So, and the same will be true if you were to subtract it, right? Same thing, you round off according to the lowest number of decimal places. All right. So with that said, let me clear this, and let's look at the A part for number 3. So they gave you this series of addition and subtraction, right? So, what would be the number of decimal places you'd expect your final answer to be expressed? Oh, one decimal place, because, excuse me, you have two decimal places here, you have one decimal place here, excuse me, you have two decimal places here, and you have three decimal places here. So as he correctly said, whatever you get here, you have to round off to one decimal place, right? So let's see what it gives. 1.25 plus 6.2 plus 8.01 plus 0.899. And according to my calculation, oh, this can be right. I forgot to subtract. 1.25 plus 6.2 minus 8.01 plus 0.899. And this is what I have on my display, 0.339 meters, right? But as I said before, I have to round off the final answer to one decimal place. So the final answer is going to be 0.3 meters. And that's how you do that. All right? Any questions about this one? Any questions? Any questions? All right. Now in the case of B involves different operations for which the rules are different in each case, because you'll notice that you're doing an addition right here. And then you're going to divide this number by the sum of that, right? So basically what we're going to do is work out what's within the parentheses first, right? And within the parentheses, you're adding 23.5 to 10. So that would give you 33.5 down here. However, the number of decimal places here is 1 decimal place, and the number of decimal places here is 0 decimal places, right? So that means that we need to round this off to 0 decimal places, right? So if you round this off to 0 decimal places, what are we going to end up with? 34. 34, right? So basically, you're going to end up with 34 here, right? Now, the next step is to divide this by the 34. By the way, 34 mils here. Can't forget the units, right? So now we're going to divide this number by 34, right? And remember, the rules for division is what? When you're rounding off, you round off to the lowest number of significant figures, right? So here we have 34, which is two significant figures. Here we have 78.860680, I'm sorry. So that will be 6 significant figures. So whatever we get here, we have to round off to 2 significant figures, right? So I'm going to divide 78.8680 by 34. And I get a long string of digits, but I have to round off to 2 significant digits. So the answer here is going to be 2.3. And we can't forget the units. We have grams divided by mil, so that will be grams per mil. And that's basically how that is done. All right? And this is something that you have to take into account whenever you're doing any calculation of any kind. You have to make sure that you round off your answer, your final answer, to the correct number of either significant figures or decimal places, depending on the type of calculation you're doing, all right? Any question about this? Any questions? Any questions? Any questions? Okay, so number 4. Let me clear this first. It says round out the following to 3 significant figures. So now they're specific here. They're saying that each of these numbers you need to round out to 3 sig figs. All right. So what would be the answer for 4A? 135 meters would be correct. What about B?
8.0.
Nope. 3 sig figs.
So
I'm sorry? No, I'm talking about B.
that'd be 100,
Mhm.
100 grams.
There you go. 18.0. All right. Any questions? Oh, grams. Don't forget the grams. Any questions? Any questions? Okay, what about C? 1,255. Rounded off to 3 sig figs would be what? Not quite. It's 1, 2, 6, and then what? 0. Because in this case here, you drop the 5, and to the left of the decimal point, when you drop any digit, you replace it with a placeholder 0, right? And of course, because this is 5, whenever the digit to be dropped, whenever the first digit to be dropped is 5 or greater, you have to raise this to, well, by 1 digit. So therefore it becomes 1,260 milliliters. Okay, and then D. How would you express that to 3 sig figs? 1.20? 10 to the minus 5 milliliters. Okay, very good. All right. Any questions about any of these? Any questions? Any questions? No questions? Okay, moving along. Let me there it is first. And then down. Okay, so now we're going to get into conversion, right? Basically, number 5 deals with converting from one unit to another. Now, some relationships between different units you should know, like 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. 12 inches is in 1 foot, 3 feet, 1 yard. But there are others that you simply won't know unless you have a brain of a computer. So that's the reason why I provided the tables here, right? So the tables you're going to have access to not only in class, but also in your exams, right? So you should refer to this when needed, all right? So going back to the assignment, basically the first one, the A part, they're asking you to go from the given number in seconds into days. Now, of course, we know, as I said before, that there are 60 seconds, write this down, there are 60 seconds, what's going on? 60 seconds is equal to 1 day. You have, I'm sorry, 6 seconds is equal to 1 minute, what am I saying? And then you have 60 minutes in 1 hour, 24 hours in 1 day, all right? So basically what we're going to do is start off with the given amount of seconds, 565, 900 seconds. And what we're going to do is multiply it by a series of conversion factors, right? And each conversion factor would represent each of these relationships that I just outlined right here. So the first thing I would do is go from seconds to days, right? I mean seconds to minutes, I keep saying days, right? So I'll be using this relationship here. So the conversion factor that I would multiply by would be where we have 60 seconds down here as the denominator and 1 minute as the numerator, all right? So the second units here and here will cancel out, all right? The next conversion factor we'll express the relationship between the minute units and the hours units. 60 minutes is equal to 1 hour. So we're going to put 60 minutes down here as the denominator and 1 hour above as the numerator, right? And then the next conversion factor is where we convert the hours to days. 24 hours equal to 1 day. And then let me just show the units canceling. The minutes will cancel out here and here. The hour units will cancel out here and here. So your final units will be days, which is what the question is asking for. All right. And then what we have to do now is do the number crunching. So 565, 900 divided by 60, divided by 60, divided by 24. And according to my calculation, now in this case, I'd have to round up to 4 sig figs, and I'm going to explain why shortly. So when I round off to 4 sig figs, I'm going to end up with 6.550 days. All right. Now, let me explain why I'm rounding it off to 4 sig figs. The main reason why is because here we have 4 significant figures, right? Now, you might be wondering, even though this was explained in the videos, why don't I take into account the numbers here, here, and here, right? And the reason why is because those numbers are what we call exact numbers. There's a difference between measured numbers and exact numbers, right? Measured numbers, as the term suggests, are numbers obtained from measuring something, right? Those numbers will have a finite number of significant digits, right? Exact numbers, on the other hand, has an infinite number of significant digits. And there are 2 types of exact numbers. You have numbers by definition, which is what we have here, right? There's a defined relationship between the minute unit and the second unit, the hour unit and the minute unit, the day unit and the hour unit, right? Those are by definition. So therefore, because those are numbers obtained by definition, those are exact numbers. The other type of exact numbers are numbers obtained by counting, right? Counting a certain number of items or people or whatever. So for example, if I say that there's a class, let's say I'm teaching a class that has 15 students, right? That number 15 is obtained by counting. I did not measure anything. I did not use a tool to measure it, right? That is an exact number, right? And that number has an infinite number of significant digits, all right? So that's important because the thing about exact numbers is that when you multiply them by measured numbers, then the measured numbers determine the number of significant digits, right? So that's the reason why I say that because we have 4 sig figs here, and these are all exact numbers, the final answer will be expressed to the same number of sig figs as this right here. All right? Okay, any questions about this? Any questions? Question? Oh, okay. So let's see if you can do this one, B part. Converting 17 years to minutes. So I'm going to start off with 17 years. Okay, so what do you think you'd multiply this by first? You're trying to go from years to minutes.
365 days.
Okay, so 1 day, 365 days would be in 1 year. Okay, I would agree with you there. Okay, what next? The years unit will cancel, by the way. What next? What's the next conversion factor?
24 hours a day.
Okay, so 24 hours above, 1 day below. Okay, very good. Day units will cancel out. What would be the next conversion factor? Jesus, not cooperating.
60 minutes.
So 60 minutes above, 1 hour below. Very good. What next? Oh, that's it, by the way. Yeah, sorry, my bad. Because it's asking for minutes, so let me erase it. Okay, so that's the setup. So let's do the number crunching. 17 multiplied by 3, oops. 17 times 365 times 24 times 60. And I got a number here. Now in this case, to what extent do I need to round this final answer to? 2 sig figs. So I got, and please correct me if I'm wrong, I got 8.9 times 10 to the 6. And the units here would be minutes. All right? Okay, any question about this one? Any questions? Any questions? Questions? Okay. 43 miles into feet. Now this one, you definitely need to refer to the tables to get the relationship. So we're starting with 43 miles. Now let me get to the table. Oops. Okay. Table. Okay. Ooh. We're trying to go from 43 miles to feet, right? Oh, that one is actually, it's right here. 1 mile is equal to 5,280 feet. So I'm going to multiply this by, I'm going to multiply this by 1 mile down here and 5,280 feet above. So let me go back to the assignment. Where is it? Oh, okay. Oh, that's not it. That's not that. This is it. Okay. So the mile units will cancel out. So let's do the number crunching. 43 divided by 5280 and oh no, multiply. Why did I multiply? 5280. Okay, so in this case, we need to round off to what? Right, 266. So when I did that, I got, and again, correct me if I'm wrong, but I got 2.3 times 10 to the 5 feet. And that's all that is done. All right? Any questions about this? Any questions? Any questions? All right. Let me clear this. Okay, 165 pounds into kilogram. So again, since I don't have a computer break, I have to refer to the table again. Okay, what's going on here? All right, so we're gonna start off with 165 pounds. And the question is, what do we multiply that by? So we go to the tables. And let's see, what's the relationship? Okay, it's okay, we have the relationship between the pound unit and the gram unit. So let me write that down here. So 1 pound is equal to 453.59 grams, all right? But we're not finished there because if I remember correctly, the question is asking for you to convert to kilograms. So that means that we need another conversion factor, which would be 1 kilogram above. Kilo means 1,000, so we're gonna put 1,000 down here. And that's it. The pounds will cancel out, grams will cancel out. And let's see what this gives. 165 times 453.59 divided by 1,000. And according to my calculation, this works out. Okay, now in this case, how many sig figs do we need to roll this off? 3. So 74.8 kilograms would be the answer. Let me just say something here about this situation here. So if you have, if you're trying to convert from a metric unit to a non-metric unit, right? So like in this case, you're converting from from pounds to grams. Those relationships are not exact relationships, right? There's one exception to this, and that's the relationship between the inch unit and the centimeter unit. So 1 inch is equal to 2.54 centimeters. Exactly, all right? That's the only situation where if you're converting from metric to non-metric or vice versa, that would be an exact relationship. This is not an exact relationship. However, it doesn't matter because you have 5 sig figs here and we have 3 sig figs here. So basically, the answer will be expressed to 3 sig figs in that case. All right? Okay. And I think what I just mentioned will come into play in the case of E. Because in the case of E, you're given 100 yards and you're asked to convert to meters. So again, we need to refer to that table. What's the relationship between the yard unit and the meter unit? And let's see what we have here. According to this, 1 meter is equal to 1.0936 yards. So here we're going to put 1.0936 yards and then 1 meter above. Let's see here. So let me go back to. Okay, so in this particular case, actually, this is 1 sig fig here. So whatever you get here, we have to convert it to 1 sig fig or round off to 1 sig fig. So that's 100 divided by 1.0936. And okay, so I got 91.44, blah, blah, blah. So the answer here would be 90 meters because you have to round off to 1 sig fig. All right. Okay, any question about this one? Any question? Okay, so let me hear what you have to say about F. Let me clear this here. And let me scroll down. So, in the case of F, you're starting from 22,647 inches, and you're trying to get to math, all right? So again, we're gonna need that table. So how will you go from, based on this here, how will you go from 22,647 meters to miles? Let me hear some ideas.
You go from inches to meters, 12 inches to feet.
I'm sorry, read that.
There's 12 inches in foot.
Okay, let's go that way. Let's see what that really does. 12 inches. Down here. 1 foot above. Okay, so the inch unit will cancel out here and here. Okay, what next?
Be 5,280 feet. Wow.
Oops, sorry. Okay, so you're using this one right here, right? So what would go up top and what would go below?
Up top would be 1 mile.
1 mile above and below you'll have 5280. All right, and I think that's it because that's what they're asking for, going from inches to miles, right? So let's see what this gives. 22647 divided by 12 divided by 5280. And according to Micah, okay, how many sig figs I need to round up? 5, right? So that would be equal to 0.35743. And the units here will be mass. Right? Okay, any questions on this one? Any questions? Okay, in the interest of time, what I'm going to do is I'm going to leave this one for you to do on your own. And I want to move on, and I'm going to leave also number 6 to do on your own. And I want to do number 7. So let me clear this here. Okay, so in the case of number 7, they gave you some information about a piece of nickel metal. It's a cubic piece. So what that means is that it's a cube. Each length of the cube would be of equal length, right? As it says here, the length is 5.25 centimeters on each edge. It says if the density is 8.9 grams per cm cube, what is the mass of the cube? So based on what was covered in the videos, what is the formula for density?
Mass over volume.
Mass over volume. All right. Now the question is asking for the mass. So if I were to mathematically rearrange this equation, what would be the resulting expression for mass? If I were to rearrange this equation, what would be the formula for calculating the mass? Mass would be equal to what?
Density times volume.
Density times volume. All right? And that's the formula that you're going to use to answer this question. Now, the density is given as 8.9 grams per cm cube, right? But the volume is not given directly, but they did give you the length of each edge. And I don't know if you learned this in your previous math experience, but the volume of a cube is equal to the length of the edge cube, right? So that means that we multiply the 5.25 centimeters, and we cube it, and then we multiply that by the 8.9 grams per cm cube. All right, so let's do that. 5.25, that is cubed, and then I multiply by 8.9, and according to my you have to round up to 2 digits. So according to my calculation, the answer becomes 1,300 grams. All right. And please note that the centimeter cube unit here, because this is cube, will cancel out the centimeter cube unit here. So your final answer will be expressed in grams. All right. Any questions about this one? Any questions? Any questions? All right. Let's look at number 8. Let me clear this first. And in the case of number 8, this is describing a way of determining density. Well, in this case, you're determining the mass. But the important thing here is that it's a method of determining the volume that is involved by what we call displacement, right? Liquid displacement, right? So basically, and I'm quite sure you've probably, experienced this or seen this or observed this. If you have liquid in a container and you submerge an object in it, then you notice that the liquid level will rise, right? And the reason why that happens is because there's a certain amount of that liquid that will be displaced, which will be equal to the volume of the object that you're submerging in that liquid. And that is what is being exploited right here, right? It says that, well, first it gives you the density of the metal, and then it says that it's asking for the mass, and then it says it's dropped in 28.9 mils of water, and then the volume increases to 56.4 mils. So what that tells us is that the volume of the metal, write this down, is equal to the difference between the 56.4 and the 28.9. So 56.4 mils minus 28.9 mils gives you 27.5 liters. And that would be the volume of the object, right? Of the metal. So to calculate the mass, we use the same formula that we used before. That will be equal to the density, which is the 9.80 grams per mil multiplied by 27.5 milliliters. And that's it. We multiply that by 9.80. And we have to round off again to, in this case, 3 sig figs. And if we do that, the answer will be, and please note, the answer is going to be 270 with a decimal point here. Because we have to indicate that the 0 is significant, right? So the final units will be grams because those units will cancel out, and that's it. All right? Any questions about this one? Any questions? Any questions? All right, let me see here. I think it is okay for me to clear this. Let's go down. Okay, number 9 says, an automobile is able to travel 900 miles on 35.8 gallons. What is the gas mileage in kilometers per liter, right? So, the normal way of calculating the mileage would be miles per gallon, right? So what I would do is divide the 900 miles by the 35.8 gallons. But the question is not asking for the answer in miles per gallons, it's asking for the answer in kilometers per liter. So again, some conversions would have to take place. So we have to multiply this. Well, okay. What I would do is I would focus on converting from miles to kilometers first, and then convert from gallons to liters. Now, it doesn't really matter which order you do it. No difference in the result will occur. So I'm just going to focus on converting from miles to kilometers. So I need to go back to the tables. So based on information provided in the tables. Okay, so what's the relationship between miles and miles and kilometers is right here. Okay, so I'm going to put 1 kilometer above and 0.62137 miles below. And by the way, I could have just as well used 1 mile is equal to this. I'll get the same result, right? So the mile units will cancel out. So we would have successfully converted up to this point to miles to kilometers. Now we have to focus on gallons to liters. So that brings us to down here. And we see here that, hold on. What did I say? Gallons to liters. Okay, let me see. Okay, here we go. We have the direct relationship between gallons and liters. Right here, 1 gallon is equal to 3.7854 liters. So the way we're going to set this up here, since we have the gallon unit down here, I'm going to put 1 gallon above, and down here, I'm going to put 3.7854 liters. All right. So the gallon units will cancel here and here. So let's go back to the assignment. So basically, okay, so all we have to do is the number crunching. So 900 divided by 35.8 divided by 0.62137 and then divided by 3.7854. And I got 10.68 and some other digits, but in this case, I need to round out to 3 sig figs. So the answer would be 10.7, and the units would be kilometers per liter as required. Yes, sir.
Can you walk through that a little bit slow?
Oh, sorry, okay. So where do you want me to start from here? Okay, so I divided the 900 miles by 35.8, right? And then what I'm doing here, I focus firstly on converting the mile units to kilometers unit. So that's where this comes from, that comes from K, right? And then now I focus on converting the gallon units to liters units, that's where this comes from, right? And then I do the number crunching and that's it.
So would you do, so how'd you do that? Would you do 900 divided by 162, 127?
Well, I did, it doesn't really matter how you do it. The way I did it in the calculator, I divided the 900 by the 35.8. And then I divide that result by the 0.62137. And then I divide that result by the 3.7854. And that's how I got the answer,
Okay, thank you.
right? Okay, any other questions about this one? Any other question? Okay, let's see, let me scroll down here. Oh, that's it. Okay, so we're finished with assignment number 1. So basically, you need to submit this in Canvas. So let me okay, what do I like this? Make it first.
Yeah.
Okay, so all right. So what I'm gonna do now is change some things in this right here. Okay, so I'm going to give the deadline as Friday. That should be enough time. And then let me go down here. Oh. Okay, so let me change this right here. Okay, so today is the 20th. And this will be available until the 3rd. Okay, and I'm going to save this. So now you should be able to upload this assignment into Canvas. And I want to remind you of something that I posted in the announcement. Make sure that you follow these rules. When it comes to submitting your assignment, make sure that it is done in blue or black ink. The reason for that is that when you scan it and upload it, what I've found is that if you have done it in pencils, it doesn't come out showing too well, all right? So make sure you do that. Make sure that your assignment is saved and uploaded in Canvas as a PDF document. Make sure that it's completed in your own handwriting, so there should be no typing work, and make sure that your handwriting is clear and legible. And I have to put that there because it seems as if students' handwriting have been getting worse over the years. Make sure also that you place your name at the top of each page. The reason for that is that when I'm printing these stuff, sometimes the printer doesn't behave itself, and I have to figure out now, which pages belong to each other, to the other when it comes to the assignment belonging to one student. All right. All right. So make sure you obey these rules, and I'm going to stop here for today, and I'm going to see you guys next week. Also, just to even though you should have watched these videos already, let me remind you that you should if you're not done so, make sure you watch the videos for chapter 3. That's not a very long chapter, so make sure you watch those videos so that you come prepared to answer questions or new problems, right?
After we do this.
Okay.
So this is assignment when I finish the courses that you do in class.
Oh, yes, also, thank you for the assignment 1, right?
Yeah,
Okay, my bad. Let me. Oh, so what I just did is for assignment 1. I'm gonna do the same thing for this assignment. All right, so let me do that right now. Thank you. What's your name? Olivia. So let me do it. Same deadline date. So let me
Who's submitting this? Who you just gave us?
this is assignment, the one we just did, is it assignment 2 or?
Yeah, assignment two is what we just did. Assignment one is the, right,
You have to go to five.
Yeah, you have to go to files first.
Files. Where do you?
I didn't see that one. Well, what's the summer for?
It's under chapter one.
right here,
Oh,
you go to files,
Oh,
right, you go to file,
maybe that looks a little too early.
right, yeah, yeah, probably, right? Okay, what was I doing? Let me, assignments. Okay, so I was about to, oh, this is, oh, here it is. Okay, so 23rd is the deadline date. And let me just do something here. So this is,
From here.
okay, and then I'm gonna save that. All right, so basically, for both assignments, the deadline date is the 23rd, right? So let me just check one more thing here. Not that. Okay, so everything is in place now, all right? So you guys are straight now, so make sure you submit those assignments by Friday at midnight. By midnight. Right? And I'll see you guys next month.
But this is the time of year,
Yes,
I was making sure I put it in the right spot.
yep,
Have a great weekend.
yeah, agree to take care. Yes, ma'am. I think so. Well, sometimes what happens is that when you send it, it doesn't come up as clear, so
That's,
can you get that like darker, like?
that's the sign.
Yeah.
We must be the sign of the time, bro.
All right, you want to submit it? Sometimes you might go, okay, you know, you send it. It's more, it's more clear. Yeah.
Have a good day.
You're gonna take care.
Thank you.
Mhm.
This Friday, I'm like, one, 90 over to speak. 90 over.
Yeah, 90 over is like jail time.
I do is sign one just on paper, regular paper, should I print it out? Free.
No, you need to break that, you need to do that now, so, I go, yeah. Yeah, 90 minutes, I mean, 90 over. I think they have a new law now, right? I think,
Yeah, it's
I forgot how much over the speed limit, but
yeah, it's jail time if it's Floyd or something, I don't know.
yeah.
I don't, so, I don't care. So is there any time we will be bringing like the textbook in?
You can, I mean, the textbook, to me, the textbook is kind of supplemental, I mean, basically, that makes up for any deficiencies, you can do, like, you know, the textbook goes into more detail.
Yeah, so I
question.
could just keep it at home.
Right, exactly, and each chapter has questions, you can,
Yeah,
you know, do those questions to get, you know, some practice.
okay, yeah, cause I was like, if we're not using it, then I won't bring it at least.
Right, you
So I'm
have
not
to,
carrying the weight.
you have to, yeah, you
I
have
brought
to,
it today.
yeah, you have to bring it to class.
I was saying.
Yeah,
I got lucky though, I got it for $40, so,
oh, really?
yeah,
We're online?
Amazon,
Okay.
open box.
Oh, yeah.
So, but it's brand new.
Brand new
so,
still, yeah.
Yeah. I wish I could have done it for college algebra, but they need my math lab,
Oh, okay, yes, yeah,
so,
yeah,
no, can't do that.
yeah. Yes, sir.
Have a nice day.
I'm in the class, I am.
Which class? Intro.
What do you, yeah, I just registered late for the class.
Oh, okay.
And I'm there from Ocala.
Oh,
So I
okay.
couldn't make it last week, because last week I had to go to the advisor in Ocala to drop some of my classes that I had to register for. Did we do like an exam or?
No,
anything great?
So far, we have covered chapters 1 and 2,
Okay,
and we did some assignments in class, right?
Yeah.
I recorded the class.
it's online.
Not yet. I'm gonna record it, I'm gonna post it, later on this evening, right?
Sounds good, okay.
Right, so you can do that, and also, I Zoom the class, for those of you who might have difficulty traveling and so on. So, I mean, the only time, well, you don't even really need to come here, because the test will be done at the testing center.
Yeah,
So basically, if you have difficulty, traveling from Okada, wherever, you can stay at home or wherever and follow the class online, because I'm zooming all my classes.
I do have to come to class anyway, because I have a class after on campus,
Okay.
so, yeah. But that was just my question, like, did I miss something?
Right, well, basically assignments 1 and 2,
Okay,
and those are due on Friday.
can I still do them?
Yeah,
Sounds good.
right, so you might want to watch the videos to see what we did, in order to help you to do the assignment, because we went through each of the assignments. So,
Okay.
Should be no problem really, and this is like the early part of the course, so it's relatively more easy, so you should be able to catch up.
Sounds good.
Yeah.
Okay, thanks so much, sir.
Yeah, no problem, no problem.
Have a great day.
Yeah, you too.